Hi there and welcome to part 2 of our C1 topic, all about carbon chemistry, and today we're going to be focusing on making those fractions that we can separate from crude oil into something that is more useful. Okay, let's have a look at our objectives for today. And just as a reminder that if you do have any problems, you can contact me on email at swood@iscacollege.devon.sch.uk, or you can tweet me at swoodisca, and I can try and get back to you as soon as possible. Okay, so our objectives for today are, by the end of this lesson you should know and understand how large chains of hydrocarbons are made into more useful smaller chains, and how the cracking process is set up on a small and large scale. Okay, so in our previous lesson we looked at the fractionating column, and we looked at the all the elements of crude oil, all the different fractions coming in through here as a gas, and some will condense immediately, whereas some will take a bit more time to condense, and they can very slowly move up. And then we've got the shorter chains at the top gradually getting bigger as we get the larger chains at the bottom here. Now obviously the big ones do have a use, but we have in a normal sample of crude oil lots of these big ones at the bottom and not very many of the shorter ones. Now what we're going to have a quick look at now is the boiling points of the different fractions. Now at the top here the boiling points are up to about 25 degrees. The next level, they are between 40 and 100 degrees. Then as we move down, they are between 150 and 250 degrees. Again, moving further down, we get to 220 to about 350 degrees, and then towards the bottom we're sort of above 350, 400 and 500 degrees down here. Okay, and this is for the fuel oil and the bitumen. Now cracking is how we actually go about doing this, and cracking takes the longer chained hydrocarbons that we get at the bottom of the fractionating column, and it makes them into two smaller chains. So we've got the long hydrocarbon here, and we make a smaller one here and a smaller one here. And this can be done in one of two ways. It can either be done by thermal cracking or catalytic cracking. Now both of them will involve heat and a catalyst, but it varies the temperature and the catalyst that they use. So how do we do this? Okay, we'll have a look at that on the next page. Okay, so how do we set the equipment up? Now in industry we use a lot of big machinery, but what we'll show you here is how they use it in the lab. Now if I just bring this picture in here, okay, what we do is we have a Bunsen burner under here and we heat the catalyst. Okay, now the catalyst can be aluminium oxide, or it can just be a broken pot, which just acts as a surface for the reaction to happen on. Now in here you can see the soaked long chained hydrocarbon that we get, that we want to break, that we want to crack. And what you do is you heat this. Now as you heat this, the catalyst, the long chain hydrocarbon will evaporate, turn into a gas and move over here. Now as it moves over the catalyst, it will break it, and that's where we get the reaction, this reaction here that we saw earlier on. Okay, so that's where we get that. Now as it moves through here, I'm sorry, I've just put the picture over the top. It's broken the hydrocarbon and we get the two hydrocarbons moving through here. Now in here we have cold water, which will cause one of them to condense. Now the one that condenses should be the alkane. Okay, this one here, the slightly longer one. And we know this from when we looked at the fractional distillation column, that the longer ones will condense at a higher temperature, leaving the smaller one to bubble through as a gas. Now this one should be the alkene. Now don't worry too much about the alkenes at the moment, or the alkanes. We will do more about these later in the topic. Now with industrial catalytic cracking, it has a similar setup to fractional distillation, in the fact that we get the long chain coming into a tower here. The tower is then heated, has a catalyst in, and then you can see along the side here you have tubes that collect the broken hydrocarbons, and they are then taken away and used or sent to where they are needed, wherever it is. So again, you can take the slightly longer ones, and normally the alkane, they can be taken and used as fuel, such as petrol. The smaller ones, tend to be the alkenes, and they can be taken and they can be used for plastics. Okay, so there we go. We have looked at the temperature ranges for the fractions of fractional distillation at the beginning. We then looked at cracking, which is basically taking a long chain and breaking it into two smaller, more useful chains. The key term there is more useful. Again, the long chains do have a use, but they're not worth as much money, so they have a tendency to use the term more useful. Anyway, I hope you've enjoyed the lesson, and we will see you next time. Bye bye.